students. In the previous session we have discussed about the work, and in this session we are going to discuss the next point of the lesson, energy. Why does it happens? Here three cases are there. First case, if a pot having a plant is kept in the dark and the plant looks languishes or it looks dull, because this is because of a sunlight, sun energy, or we can say solar energy. Second one, on increasing the volume of a music system or a TV beyond a limit, the vessels in the house start vibrating. This is because of a sound energy. The third one, collecting sunlight on a paper with the help of a convex lens burns the paper. This is because of a heat energy. Here solar energy is converted into the heat energy. See, student, you have learned that energy exists in various forms, like a mechanical, heat, light, sound, electromagnetic, chemical, nuclear and solar energy. Now let us learn the definition of energy. Means the capacity of a body to perform a work is called energy. The SI unit of energy is joule. In Celsius system, the unit of energy is erg. Here, Celsius means centimeter, gram, second. Student, now let us discuss the next point, that is a kinetic energy. What will happen in the following cases? Here also three cases are there. A fast cricket ball strikes the stumps. Second one, the striker hits the carom board. Third one marble strikes another in a game of marbles. See, from above three cases, we understand that when any moving object strikes to a stationary or a rest object, the rest object gets moves. This is called as a kinetic energy. Now let us see the definition of kinetic energy. The energy which an object has because of its motion is called its kinetic energy. In other words, we can say a kinetic energy is equal to work done on the object. That is, here work done means force into displacement. Now let us discuss the next point, that is expression of kinetic energy. Suppose a stationary object of mass m moves because of an applied force. See, any object moving has its mass, that is m, and start moving applying a force. Let u be the initial velocity. Here u is a 0. Let the applied force be F. F be the applied force to the stationary object. This generates an acceleration A in the object. When we apply the force, the object start moving, means here acceleration is generated. After the time t, the velocity of the object become equal. Change in velocity is equal to v. Therefore, the displacement during this time is s. Means the object is moves from one place to another place. That displacement is s. Here, the work has to be done to move the object. Therefore, work is equal to force into displacement, that is F into S. According to the Newton's second law of motion, F is equal to m into A. Here A is left in the equation first. Now F is equal to ut plus half of at square. Here u is 0. Therefore, S is equal to half of at square. We know that W is equal to F into S. Therefore, W is equal to, put the value of S here, half m square. This is equation 3. Now, using the first law of equation of motion, V is equal to U plus AT. Again here U is 0. Applying squaring on both sides, V square is equal to 80 square. Now put the value of 80 square in the above equation. That is 80 square is equal to mv v square. Therefore, the equation becomes W is equal to half of mv square using the equation 3 and 4. Therefore, the kinetic energy gained by an object is the amount of work done on the object, that is W. Therefore, W here is equal to half of mv square. This is the expressions for a kinetic energy. This is very important for the point of view of your examination. Student, in this session, we have learned the kinetic energy and energy and the expression of kinetic energy. See, all these points we have learned. Thank you, students.